a 10 kilogram block is released from rest with an initial velocity of 0 meters per second on a rough incline. The block moves a distance of 2 meters down the incline in a time interval of 0.95 seconds and acquires a velocity of 5 meters per second. First question is, what is the net work done on the block during this process? So what I'm going to do is I'm going to draw it all out. Let's just say, here's the incline. All right. Say this is 45 degrees. Let's put the block at the top. This is the 10 kilograms. Then it slides all the way down to the bottom. Let's see. The initial velocity is 0 meters per second. And then the final velocity is 5 meters per second. From here to the bottom. All right, let's just this is going to be 2 meters. Okay. So what we're going to do is I'm going to get the work equation. Work equals changing kinetic energy, which that also equals to work equals 1/2 mass times velocity, or final velocity squared, and minus 1/2 mass times initial velocity squared, which then that would equal 1/2 times 10 times 5 squared minus 1/2 times 10 and times 0 squared, which would ultimately equal, let's see, 1/2 times 5, or 1/2 times 10 equals 5, and then times 5 squared would be 25, which then that would equal 125 joules. So that is the total amount of work that is done on the block. That is the net work done on the block during this process, is 125 joules. And then second part to this question could be, how much work does the gravity do on the block during this process? How much work does the gravity alone do? And which for that, we can use the equation. Let's see, let's make this part A. Make that part A. Then we can do part B. For part B, looking for the gravity, or how much work the gravity has done, which that would be work equals mass times gravity times height 2, or the final height, minus mass times gravity times the initial height. And we don't know the height yet, so let's make this height 2, and then let's make this height 1. And then, so for this, what we would want to do is, let's take sine equals opposite over hypotenuse. And then what we can take that and then plug in our 45-degree angle. So then sine of 45 degrees would equal the opposite over our hypotenuse, which is 2. So then that would equal, and then to get the hypotenuse, or I mean the opposite side, which would be our height, what we would do is we'd move that 2 over, obviously, and let's see, get my calculator out. Oh, if I can find it. Okay. All right. One second. Okay. So once we plug this in, let's see. Let's see, so that would be 1.41. Okay, so the height would be 1.41 meters. All right. And then, so then we would take this height and use it in this equation here. So then we can also plug in, so for the work done by gravity would be the mass, which is 10 kilograms, times gravity, 9.81, and then times the height, which is 1.41 meters. 1.41. All right, let's plug that into our calculator. So that's 10 times 9.81, then times 1.41. And that's going to be 138.3 joules. Oh, let me box that too.